We're going to look at 32 through 38 here, which are all exponentials and logs. So in this first section, we're matching the equation to its original graph and to its inverse graph. I'm going to specifically look at 33 first. Y equals natural log of x. This is a log with a base of e. So of these four graphs, the two that are log graphs are A and C. So between A and C, we need to see which one would be natural log of x. If you have a log with a base of e, this base e is a number that's bigger than 1. So that means the log graph should be increasing, which would be graph C. So the original graph is graph C. The inverse graph should be an exponential graph, which is also increasing. So since the base here is e, the base on, for example, number 35 is an exponential with base e. The only increasing exponential graph here is graph D. So D is the inverse of C, and vice versa. So the original graph for y equals e to the x would be graph D, an exponentially increasing graph, and its inverse is graph C, an increasing log graph. On number 36, we have an account with $500 with an interest rate of 3.5% compounded continuously. So the key word here is continuously. The formula here is PE to the RT to find how much the account is worth. So write an equation that represents the value of his account. So the principal is the $500. E to the 3.5% as a decimal would be 0.035, and then times T, which is the number of years. How many years will it take for his initial investment to reach $10,000? So we're going to look at solving this equation. To isolate the exponential, I can divide by 5,000. So this would be 2e to the 0.035t. Now in this case, the exponential has the variable. So I'm going to use logs. So if I use log form here, this would be log base e 2 equals 0.035t. Well, in this case, log with base e is actually ln. So ln 2 equals 0.035t. At this point, we can use the calculator to determine the solution. I need to do ln 2 divided by 0.035, which gives me approximately 19.8 years. Now, lastly, we're going to look at matching a log equation to its asymptote. So let's look at just one of these as an example on problem 38, number 4. In this log equation, an asymptote means where the graph is approaching but never actually hits. So in this case, we're going to look at what makes the argument of the log equal to 0. The argument of log would become 0 only when x is equal to -4. So this is the equation of the asymptote. So this would be equation D.